Good morning, good afternoon, or good evening, depending on where you are in the world. And welcome to this Techstrong learning experience brought to you by the AI Infrastructure Alliance. My name is Cody, and welcome to Techstrong Learning. We have an exciting panel ahead. Before we get that ball rolling, we do have just a couple of housekeeping notes I'd like to review. Today's session is being recorded. So if you miss any of our discussion, perhaps you'd like to rewatch or maybe share with a friend. The on-demand recording will be made available shortly after we conclude this live session today. If you'd like to engage with us, there are a couple of options for you to do so, and they're all going to take place on the right side of your screen. The first option you'll see says chat, and that's exactly what you think it is. We want you to start warming that up for us right now by letting us know from where you are joining us today. If you have any questions, we do want you to direct those to the Q&A panel. That just helps us keep track of them, and we'll try to get to them as soon as we can. Now, before we close out, we will be giving away 4 $25 Amazon gift cards, so be sure to stick around for the duration of our conversation. The topic of our conversation today is painless deployments, and I'm joined by a group of panelists led by Lee Baker, General Secretary, AI Infrastructure Alliance. We have Manasi Vertak, founder and CEO of Verta, Mike Vizard, Chief Content Officer here at Techstrong Group, and Mitchell Ashley, CTO of Techstrong Group and Principal here at Techstrong Research. So Lee, Manasi, Mike, and Mitch, thank you all so much for joining us today. Lee, would you like to go ahead and get our first question started?
Wonderful. Thank you, Cody. We've got a good panel here, and we've got a great topic to tackle today. We're talking painless deployments. You've gathered your data, built your model, linked your library and code, and now you've got to deploy that model. So, Mitch, I'm going to throw the hard pass to you first and foremost. Why is deployment so challenging, and is a painless deployment as rare as a snow leopard?
Is it an oxymoron? Painless deployment, so like military intelligence. Well, so it seems like, at least traditionally, historically, we're sort of crossing over from one environment to another, right? And in the software world, we've eased that a lot with automation and making deployment not a rare thing, but a common thing by doing it frequently in much smaller steps. I think in the AI world, and my AI experience goes way back into doing Lisp and Prolog and expert systems, back in the day, which were pretty difficult to get into production. But I think now the challenge is that we do so much more experimentation, data engineers, AI engineers, with the models and with the data that we're consuming, and then moving that into a production environment, which operations likes to be stable and likes to be reliable. So for the apps that depend on that, or whatever the models and the systems are supporting. So I think that's where kind of that rub comes in, and it doesn't have to be that way. I think the more earlier and the more frequent that we deploy our AI models and data into production, the better, because by the time it really counts, you'll have done it dozens of times, not once.
Manasi, let me follow up with you on that, because we talk about issues with DevOps all the time. And now we have data scientists using ML ops to create models, and then we want to deploy them. And there's this intersection with the DevOps world. And I'm trying to figure out how much of this is a technical issue versus a cultural issue. And we're just kind of having two different folks who speak entirely different languages trying to describe the same proverbial elephant.
Yes. That's a great question. I'll preface my question with a bit of background. So my background is technical. I'm the founder and CEO of a company, but I have a PhD in computer science. So have done both building models, and at my company, we build software to get models into production. And so have done the software building side too. So we talk to a ton of people who are trying to cross the chasm, is really overused, but go from research, as Mitch was saying, to production. And I would say there's a few different reasons why it's hard. And to your point, Mike, it is technology. It's also cultural / a difference in the skill sets. On the data science side, you're hiring statisticians, you're hiring data scientists, PhDs to build models and do experimentation, and that's very different. You're trying things out. You are, you'll build hundreds of models. You'll hyperparameter tune them, and no one cares if that is in a Git repository or it's reproducible, all of that. Whereas once it gets to production, it is your ML ops engineers, it is your IT teams, it's your DevOps engineers who need to take those models and then turn them into a production service that needs to meet SLAs, that needs to not fall over, that needs to scale. And so I would summarize by saying one is the difference in skill sets, because data science doesn't necessarily know enough software engineering. I think a lot of people are getting upskilled, but not production level. On the other hand, the IT folks don't really know how models work or what they should be looking out for. And so this handoff is super, super painful. I think we can reuse a lot of DevOps concepts, which we've seen a lot of success doing. But that handoff is not necessarily the same as from dev to ops. Hopefully that adds more color.
Yeah, that's a great take. Sorry, Mitch, you were going to say?
No, I was just going to point out, I think that's an excellent point, is that think about who's good at what things, right? And whether it's DevOps engineers, software engineers, and operations, deploying code into production. They've been doing that, right? They know they've got the scars to show for it, maybe the gray hair too with it. And if you're a scientist, a researcher, a data analyst, kind of person who's not used to doing that thing, don't force them, to squeeze out of the tube of toothpaste and put the toothpaste back in. Right? Work with each other as a team. Modesty has a company that does this. There's technology and people who have expertise in this, so that you can get a combination of, we need the ability to experiment, right? But we also need things to be stable and not, change at a moment's notice and crash the whole system or whatever it is. So there's a balance there. And because you don't want operations folks saying, I have no idea what this is. It's a black box. Can't look in it because I don't understand it. So let's get that person up at 3 a.m., right? Let's figure out how we can flow that in and then work on resolving issues when they come up.
Yes, data scientists don't enjoy getting paged. No one enjoys getting paged in the middle of the night, but not data scientists for sure.
Mm-hmm.
Well, Manasi, I was just going to ask the question at the AI Infrastructure Alliance. Our vendor members and the practitioners with whom we engage, they often talk about ML best practice, centers of excellence, good discipline through the pipeline. Now, it's all well and good to talk in those terms, but what actually does that look like for an enterprise that is struggling with the rigor of a stable and sustainable ML pipeline?
100%. And I'm a fan of the work that the Infrastructure Alliance is doing, because it's actually bringing together and bring together tools and practices and trying to help define a standard, which is very, very sorely needed. I think most folks are struggling to figure out what this pipeline looks like. It's a lot better than I would say 2 years ago, when MLOps was new and folks didn't really know what MLOps was, what fell into MLOps versus DevOps, those things. Some things that we've seen work well at the enterprise level. So when you have 200 data scientists, 50 data scientists, and there's variations of this at the smaller levels too, is there's usually we like to divide the world into, there's the data science world that is building the models, then there is the production world, which is typically a IT or platform team. And both of them tend to have centers of gravity. I would say these take different names and flavors. The data science centers of excellence so far seem to have focused on the training side or building model side, not as much on the deployment side. And so we're seeing ML platform teams emerge to serve that same purpose. And these folks are either managing the tools to perform the handoff and then run models in production, or they're at least instituting best practices, to your point, Lee, where they're saying this is how you should be constructing your pipelines, your Jenkins, your Airflow, whatever the components are, and then providing those tools along with some glue for individual BUs to use. So the ML platform teams, I think, have been a real net win. Now they're called different things. Sometimes they're called like advanced technology group. And okay, that is so vague, but that's what they're called. It could be anything. And to, I think, Mitch's earlier point, there's data also plays a big role, right? We think of this as your data engineering, your data science. There's also code that makes all of these models production level or serves. And so we think of it as a table with three legs, I guess, a stool with three legs. You have your data, you have your models, and your code, and something needs to kind of bring them together.
Hey, Mitch, are we overthinking this? Because it seems to me, every time we don't understand something, we call it magic. And, I guess word processing was magic back in the day, so it was called AI. But at the end of the day, so I trained the model, and the model created the inference engine, and I stuck it in a repository, and I needed to ship it out. So is it not just a software artifact or a new type of software artifact, and we should just think about it in those terms and manage it accordingly?
Well, first, I can't believe you would ever accuse us of overcomplicating things. So that's a first. I created a term long ago, overcomplexification, which defines itself. Anyway, I think there's a really good point in that is, don't make it mystical, right? I mean, if you want to translate this into a traditional IT and ops world, talk about it as data storage and retrieval, right? There's massive amounts of data we need that the ML engines or logic are building on. There's a lot of traditional data management things that we do for those things, whether they're in a GCS or an S3 bucket or wherever that data is located. There's also frameworks, whether we're using like TensorFlow or PyTorch or Scikit. There's many of those things, right? Well, we have those structures. It's Kubernetes and cloud native. It's, other frameworks, and those people understand those kinds of tools in an operational sense and can be trained on that and understand that it isn't just a massive amount of code that's being, Python code that's being shipped from A to B, and B is production. It's in a structure that can then also be fed into observability tools or operational tools, things that ops knows and understands. So we can overcomplexify it, or we can translate it and say, here's how we plug it into a world that other folks know, and then help with the learning curve around those frameworks and things.
Mitch, I want to extend the thought there, because you're right. Manasi talked about kind of architectural frameworks or tools for architecting your pipeline. You're talking about libraries and frameworks, but increasingly this is being abstracted away. So how much should the modern organization worry about this, and how much should they consider, well, actually this is going to be, I'm using rely on generative models, so actually I shouldn't concern myself with the nature of the deployment platform. Manasi, what's your kind of perspective on that in terms of what's happening in the back office? How much should that concern the modern enterprise?
Yeah, that's a fair point. I'll go at it a few different ways. I think at the end of the day, models are software components. They run as services in most cases. And so we should absolutely be using as much DevOps. Like, people shouldn't need to know whether I'm calling. Yes and no. People shouldn't need to know that I'm calling a model if it's just an API. At the same time, because models are stochastic, and it's not like code where I know it's going to generate a 0 or 1 and I know exactly why. It's going to generate a 0 or 1 depending on the probability I should do different things. And so there needs to be a touch more nuance in my experience in the consumers of models. And I think the consumers of models have not received adequate attention, in my view, because we glorify data scientists and MLOps engineers. Yes, very important, but someone is consuming the model and making the product actually useful. And so making sure that they can actually understand how to use this service, I think, is super critical, and that still remains an open problem. One place where I think DevOps and MLOps is different, and this is a maybe cultural thing that you guys would find interesting, is if you think about the number of services that a developer develops and maintains over the course of their career, their team, whatever it might be, it's usually, let's call it less than one or less than two. Like you might manage your authentication service, you might manage your database service. If you think about data scientists, each of their models becomes a service, and these people work on dozens of models at a time. And so I like to characterize it as number of services per developer. And that number is 10x higher in data science land than it is in software land, which means for software systems, your ability to quickly build these services, update them, manage them, deploy them becomes 10x more important because you're doing this every day, as opposed to in a software system, you might have half a dozen at a small company, and that's it. You have 6 services, and so it's very easy to maintain. So I think that shift has been really interesting for us to keep in mind as we try to reason through some of these problems.
Yeah. Manasi, can you help explain something to me? Because you might have figured out by now I'm kind of the simple guy, but I go talk to the data scientist folks and they tell me about features, and then they get all these features and they use the features to kind of build the model and they stick it in a feature store. And I look at them and I go, well, that sounds like a Git repository. So why not stick it in a Git repository in the first place and just make it easier for everybody? So like, why do we have, what is a feature store and how is it different than a Git repository?
So I'm a bit biased. My PhD was in databases. So every time I look at feature stores, I say, that's a data warehouse. So to your point about the Git repository, I think data warehouses are actually a reasonable analogy in my view for feature stores. Like there's more complicated versions of it. And I'll simplify it to say, in a large enterprise, a lot of the core data sets or features that are used across models are the same. And so you need a place where someone can build that feature one time and others can reuse them. And that's the number one purpose of a feature store. There are secondary things like offline, online, there's backward, sort of you're repopulating data backwards in time, things like that. But at the beginning, it's just a way to share data and share your features. So I feel like data warehouse is just a fine analogy. And to your question about Git repos, just like you wouldn't store your data in a Git repository because it was not meant for data retrieval, even if you have Git LFS and things like that. So databases are great. And the thin shim is actually how a lot of people start with feature stores is, okay, there's a thin shim on my warehouse where I can query features and reuse them. So hopefully that answers your question. If not, I can go deeper.
Manasi, it reminds me of AI ops, and one of the principles behind AI ops, or I think what it's about, is really about data management, right? And because scientists are not worried about terabytes of data, managing how to manage that, right? They were writing machine learning algorithms and tweaking the model and things. And that's where that sort of operational expertise of managing data across multiple environments. So as you're saying, you may be doing a shim off of your data warehouse, or maybe you're creating the next generation of a data warehouse or data lake, essentially what it is. And think about it that way. Maybe you have to translate it as features are databases or features are warehouses. Think of it that way, ops folks, and they'll be right there with you, right?
So this for me is kind of the point of anxiety, because modern media has jumping on the bandwagon of horror stories of AI, and usually most of those are misplaced and misapplied. But really, for me, the anxiety is around kind of understanding which features that your model is using, and thereby kind of having the appropriate guardrails. Mitch, what's your take on kind of what appropriate ML and data governance looks like, and how do you articulate that to an enterprise who's looking to harvest a ton of customer and personalized information?
Well, you throw the easy questions to me, don't you? Oh my gosh. So, I mean, you're touching on a lot of things around potentially privacy and PII and that kind of information, and how is that used in your models and your relationship with your customers about the trust of not using their information in appropriate ways, or whether you're supposed to at all, or or abusing that privilege. I think it's an important point. I don't know that I have a simple answer to that question, other than ultimately our customers trust us because we keep their data. We provide services with that. If we're using that data in, even if it's anonymized variations of it, if we're using that in our models to improve the service offering to them, etc., I think we have to be communicative to our customers of how we're using their data, not in technical, deep, complexity ridden terms that they're going to go, I have no idea. It looks like another software EULA to me. But let them know how we're using their data. Now, on the other hand, the data that we're generating about the telemetry of the business, let's say you're in the installation of Wi-Fi in the home, and you have a large database of all the troubleshooting or all of the scenarios, that kind of thing. That's less of an issue about the governance of that per se, unless you do have personal information. So I'm gonna punt and give this one to Manasi because it is a complex issue.
I think about these problems day in, day out, every day. So I have opinions on all of these. So you be careful when you ask me. This is very topical. If you're following the EU regulations, the EU AI Act went through its next stage, where they added a few more amendments to cover generative AI. It goes up for a vote in May, and we work in the space as well. And so what we're finding since 2023, suddenly everyone seems to have woken up, trying to get their models, let's call it, in order. And that's being driven, what we think, is by two things. One is generative AI has just brought AI into our homes in a way that as it was never done before. And so everyone's worried about, is AI going to do bad things? Is this thing regulated? And so the people who are actually building the models, even though they're not generative models, suddenly are being asked, oh, what kind of models do we have? What's our exposure? Can we bring in generative AI? What will it do with respect to our data privacy and data governance and all of that? And the second, so one wave is generative AI, the second wave is regulations. So EU AI Act is just one. There's the 80 PPA that was introduced last year in the US. The NIST risk management framework is another one. So there seems to be a wave building of, okay, we need better AI governance. And I think we will see that come to fruition later this year, and then of course the subsequent years. And AI governance, as we said earlier, it's kind of, AI is a combination of data, you have models, and you have code. So governing AI also, in my view, comes down to governing the models, governing the data, and then governing the code. Governing the code is easy. IT has been doing that via IT practices like scanning systems and making sure you have change management in place. So that's taken care of. I think AI governance is going to depend heavily on data governance, and the data catalog movement, the GDPR, and so on have really forced a lot of companies to put in reasonable sort of controls on data. The model governance is still loose, and that's where we'll see a lot of changes happening this year. We have this perspective that everything starts from a model catalog. And so we have been pushing people to at least inventory your models. Like, you cannot have models running on your laptop and then no one knows. You also need to tie them together. What data did this model use? To your, I think Mitch's earlier point is like, did we use PII data that we weren't supposed to use? If you don't know what data was used, then you have no idea. And so AI governance is coming for sure this year. It's got to be this trifecta that, again, you're pulling together. And I think we can draw upon great work in data and IT sort of governance, plus the bias and responsible AI angles that models will bring with them.
All right. Well, we have a follow-up question from the audience about this particular issue. And I'm going to kick it to Manasi. But basically, it's like, okay, well, let's say we have an application group, and each application group has 10 to 12 models, and somewhere along the line we have 400 application groups. So what could go wrong in all of that with the level of scale that we need? I mean, how do we approach that?
Yeah. So That's why you need better model management, honestly. Like
You
that.
just described what could go wrong.
Exactly. Just starting with, think about, so we were on, well, we seem to have lost somebody. We were on a monolith system, like monolith software systems for the longest time. And one argument for that is like it helps you manage the complexity or risk. When you go to multiple microservices, suddenly there's a lot of the service calling that service. And this is very similar, except these models and their outputs are stochastic and you need to calibrate them. And so if your product is impacted by a model 2 steps removed from you, good luck, because the model might break, the data pipeline might break, your code might break too, but you hopefully have tests. And so tracking the dependencies there becomes super critical. And I think very few people do it today. Again, this is where I'm hopeful that regulations will force people to have better hygiene on models and these dependencies, because left to our own devices, data scientists might not really want to do that. Like they have enough things to do. But good luck, 400 applications. I think it's better management and keeping track, as it adds some tedium, it adds some friction, but it's going to help debug production issues a lot faster if you have that in place.
All right, we got one more question that follows on to this conversation, but I'm going to kick it over to Mitch. So, well, ultimately, we see some separation in concerns here where the data science team will build the model, but the IT folks will be in charge of governance and implementation. And today we're asking the data science folks to do too much.
It's a great question. It's a good point, right? AI engineers, data engineers, et cetera, model developers don't think of themselves as living in an ops world, right? That's not what they do and what they do well. But the point about governance, I mean, I think what's really interesting is we've sort of, Chat GPT, generative AI has essentially gone mainstream, right? Everybody can have it now. And that's why it's such a big deal, because now we can all see how it might impact us and what it might do. And there's the regulatory path that Manasi talked about and what's happening there. There's also the reactionary, sometimes overreactionary of Italy's banning, generative AI, or companies banning the use of it because we don't understand it yet. So I think if you're incorporating AI into your products, we need some kind of fair disclosure, whether they're rules or frameworks, or you're just doing a good job of it because you want your customers to not feel you don't want to destroy the trust that you built with them. And I think that's part of that governance role. It's not just a kind of regulatory framework meeting requirement. Yeah, that's there too, but there's an external market component to AI and how we're using it in the world, and that's going to change rapidly, right? I mean, if you say we added generative AI into our ticketing system product that we provide to the market, great. Well, how? And is the stuff I'm putting in there going into your model, or are you using other sources for that? And people understand things like OpenAI as the general tool that you can use and don't realize that, there's licensing where you can control and creating large language models based on data that vendor is feeding into it. But it is controlled. It's not like ChatGPT turned on loose on the world. So we could sort of shoot ourselves in the foot. Maybe we already are with just kind of throwing it out there, and all the science fiction fears come true in days instead of decades.
Well, look, let's talk about a real fear in the here and now, and particularly felt by a lot of software vendors who are now having to reframe where they sit in the pipeline in reference to generative AI and large language models. Can't even say it, much less write them. So a lot of software vendors are struggling where they sit in the tool chain. So Mercy, should they be worried? Should they be considering how their business needs to repurpose and be fit for purpose?
I'll ask a clarification. Do you mean vendors, or do you mean third parties that are using ML?
No, sorry. The tooling companies who have kind of built a very specific component or tool in the tool chain?
Makes sense. We're, Verdo is a tool vendor in the ML space. I don't think so. I think I can at least speak from a startup perspective. Mid-size, large is different. I feel like startups, there's one thing that you're really good at, and you want to be good at. If you increase your aperture too much, your products are going to be watered down and undifferentiated. Traditional ML questions like how do you deploy, how do you catalog, how do you manage, how do you monitor, are still very relevant. And of course, training. There might be flavors, say, running on GPUs that become more relevant in the LLM age, or during training, maybe fine-tuning the model becomes more relevant, but your core competency or business, I think, still is very relevant. You might need to add features to support LLMs, but I think startups should focus on their core expertise, because there's a lot of people trying to solve LLM problems. And so I think there's also a risk of just getting lost in the noise.
Mitch, we've seen
And
this
there
before.
certainly is a lot of noise.
Mitch, we've seen this before in the land of DevOps, right? A lot of excitement about deploying and continuous delivery, but the only thing more painful than deploying is rolling something back. And every AI model on the planet is subject to some drift, so we're going to be rolling things back by definition almost to update them and replace them. So do you think we're giving enough thought to the whole full life cycle here?
Well, I think if you apply what we've learned through DevOps and what we've learned through architectures like cloud native, where we break software down into much more smaller elements, components of work, and then iteratively improve those and iteratively deliver them to production, whether it happens automatically in a Netflix kind of world or it goes through a governance or checkpoint process before it gets released into production. If you're rolling back very large systems, very large quantities of data, that's painful. That's heart surgery, that's brain surgery. If you're rolling back an iteration of a component of a model that you're managing well, that's much easier to do, but harder to do. I mean, harder to manage it that way. So there's definitely some lessons from the past, but we tend to learn things the hard way. I think, crisis tends to foster a lot of learning. So I would imagine we'll have more opportunities to learn in this space.
We've got a great question that's come from the chat. So one of our participants has mentioned kind of training for GPT-3 uses 1.3 gigawatts an hour of electricity. He hasn't sourced that, so I don't know where that's from. But essentially, what he's talking about is the disproportionate cost of training models. And then another one of our guests has referenced about the green energy implications of ML and deployment at scale. Mercy, is that something that people are thinking about? Is that a consideration at board level?
I would say this is very much on people's radar because a lot of companies can't afford it to begin with, because this is one model, mind you. You want to fine tune and do things with the model. And so on that front, I would say this is very much on people's radar. The great thing is researchers, particularly from Stanford, have come up with ways to train smaller models more cheaply. So this is the whole llama, alpaca, and that whole set of models. And then Databricks has a model called Dolly. And so ChatGPT took a lot to train, but collectively the community is coming together to figure out ways to reduce that training cost and just make it faster overall. So I have a lot of belief and faith that it will become cheaper soon. There's also new hardware that will come up that will make some of this training easier. So I think over time, we won't be looking at those kinds of massive costs. The other thing is not everyone needs to train ChatGPT type things from scratch. That's the benefit of pre-trained large models, is you can use them and then fine-tune smaller models that are a lot cheaper to do. I would liken it to, there's NASA spent a lot of money to, say, build the first spacecraft, and then others could benefit from it. maybe at a fraction of the cost. So sometimes there's one big push and then others can build off of it. I'm hopeful that that will be the case. The green energy implications are definitely on, I would say, at least one section of the community's minds. There's one part of the community that's just trying to stay competitive with ChatGPT and not really thinking about the environmental implications. I know researchers are thinking pretty hard about what does this mean. And maybe there's an interesting way that this comes back to the ESG conversation that's had at the board level. And there will be some constraints, or there'll be a rating on how energy efficient is your company, particularly with respect to your AI and ML. I think we're at the super early innings there.
Monitoring tools come this way. Hey, Mitch, let me ask you something. If I understand this correctly, we're going to see multiple large language models being implemented for different use cases for different types of data. And then we've got a bunch of machine learning based models that are optimized for certain things. And then there's a bunch of stuff floating around like deep learning algorithms, formerly known as neural networks. Are all these things going to be managed collectively and alongside each other? Are they different use cases and they're managed in isolation from one another? How do we kind of approach this or think about this?
I think the way to think about it is, well, first of all, ChatGPT, generative AI, what we see today, that's the brute force model. That's the, like, let's take the biggest problem and try to solve it with the most data. And I'm not being critical of it, but that's kind of the evolution of where we are in this. And then now the refinement of that, as Manasi was talking about, if you may have a medical industry, or maybe it's a specific part of, a cancer model or whatever it might be, and that's where a lot of investment in the startup world is happening with VC money, is taking that, and the number of people that will be able to make a Microsoft level investment into building a large language model, Google and a few others, there's not a lot of companies that can do that. But the people that could invest in, here's patient data that we can take the PII out of it and add it to a model about the efficacy of a certain drug or a procedure or whatever, that can be super helpful. But to your point, that's a different process of, what data scientists, data engineers are doing is labelizing or tagging content that's going into the large language model. That's different than building machine level or machine learning algorithms based on data and then preparing data to go into those algorithms that you're building yourself, versus a neural network is another kind of model that you're creating based on a certain domain. So I'm not saying that they're all totally distant, unrelated to them, but I don't think you can all label it into one bucket and say we're going to manage it one way.
I'll jump in. I have a slightly contrary opinion to that.
Let's hear it.
Part of it is like we are using manage to maybe mean different things as it was in database management too. Is like, are you storing? Are you deploying? I think the way that these models are being built is going to be very different with GPT, to Mitch's point, like GPT or fine tuning and regular ML. When it comes on the production side, all of these are going to have to work together in one service. If you look deeper into generative AI applications like a chatbot or a search assistant on a large corpus of data, it's using ChatGPT, then it's using regular ML models, then it's using database queries, then it has a UI on top of it. And so I think what we're going to see is all of these models need to interoperate really effectively. And that's where software principles of, API first and, microservices, all of those are really critical. Once it gets to production, I think having a common framework to manage at least the production deployments of these models will be critical, so that you can have a bird's eye view on the previous questions, like GPT is calling this other thing, which is calling this other regular model, and then we're combining it. So while the ways in which you're creating these models might be quite different, I think they need to come to a common ground, maybe at the catalog or inventory level, the equivalent being your Artifactory or your Git. You could build your software a lot of ways, but it needs to come to the same place in Artifactory, and then it'll get farmed out. And so I think that could be an alternate universe.
And Modesty, isn't that also a lot of what the frameworks help provide, right? Some of that structure around it, so it doesn't look like, big black boxes and things.
Exactly.
So am I going to need an AI system to manage all this? Because what you just described to me was like, my AI dependencies have AI dependencies have AI dependencies. So like how this gets to a level of complexity that my mere mortal mind can't wrap.
It's called Skynet.
Was that a serious question? The complexity is someone was comparing this again to a shuttle or like one of the space shuttles and so on. I said, yes and no, the complexity is the same. What makes this even more challenging is you can trace bugs down to single lines of code. You're never going to be able to do this with these models. And so there is the complexity that comes from let's say multiple pieces being strung together, but there is emergent capabilities with these models, and we don't have good ways to reason about them.
Manasi, let me kind of get a little bit more specific on the hand grenade of that question and ask, with all of this complexity, are we seeing some new functions, some new skill sets emerge? I'm hearing things like data product manager or functions where there is a certain specificity to what they're doing in the pipeline.
I'll speak about the things that I'm most closest to, prompt engineering and so on. It seems like that's a thing and is here to stay and so on. From the deployment and governance and monitoring standpoint, I think that there is going to emerge disciplines around AI governance, just like you have disciplines around data governance. So there's a data steward, and there's a data owner, and there's a data platform team, and so on. So the parallels in AI that I expect will emerge are going to be the AI governance team. There's a AI steward, multiple AI stewards. There's people who develop these things. There's also folks on the model risk side. Banks have had these, banks and insurance companies have had them for a while, model risk managers, but there will be model validators and evaluators. And if EU kind of has, gets everything they want in that regulation, there's also going to be people who look at training data very carefully and make sure it's not biased. And so I expect that data and the sanitization of data, making sure it's not biased, is going to be an area where we will need people. And then the AI governance will also be an area. Monitoring is another interesting one because the outputs of particularly LLMs are very hard to validate. It's going to bring up new stuff each time. And our current metrics aren't just good enough to adapt to that. So I think those are the three areas where I definitely see more newer skill sets kind of emerging.
Honestly, there's also kind of a middle tier like machine learning engineer, right, versus scientist, data scientist. That's less about experimentation and more of kind of adding the structure, discipline, the framework, kind of the software engineering ideas behind code and models that we're deploying. So I think that may be part of that intersection between creation and operations too, is as actually people whose role is applying sort of the software and deployment disciplines to this too, because those are some titles that I'm seeing.
100%. I think MLOps engineers are here to stay. And one of my gripes kind of last year was I wish more DevOps people would go into MLOps because they have the expertise. I think there's a bit of upskilling required, but once they do that, I think they'll have access to a lot more, a higher pay level, potentially more jobs and everything. So, since this is DevOps run by DevOps.com, I hope more people from DevOps do get into MLOps.
Putting a plea out there.
Now
Sorry,
everybody
Joel.
wants to know what does an MLOps engineer make anyway?
Whatever they want to right now. I don't know. I don't know what the range
True
is.
story. They're one of the hardest roles to hire for across all the people that we work with. Is like, can you help find us MLOps engineers? Very hard skill.
Let me ask you an esoteric question for the grid. So let's just say that I create an AI model that's optimized for a specific process. Let's say I want to negotiate, the price of shipping containers, and I'm the buyer. Now you, as the seller, created an AI model to optimize the sale of the consumption of the containers. So won't our two AI models just meet in the Ethernet someday and just collide and crash to the point where it kind of becomes a zero-sum game and I got to call you up and negotiate the last minute of this thing,
Yeah, I would be scared if they collude. If they collide, that's
Yeah,
okay.
exactly.
If they collude and then both parties are in trouble, that's when I'm really worried.
When those two AI engines go form a new company to compete against you, that's when you need to worry.
Yeah.
But you could see kind of a, back to a database deadly embrace situation, like where locks conflict and AI models are negotiating it in incompatible ways, and there's no answer to it. It's kind of like deep thought computer back to Hitchhiker's Guide. What's the answer to 6 times 9? 42. No. But that's not the question is what matters, right? So of course, I think we're going to run into that kind of thing, but then somebody's sort of got to hit the pause button and say, okay, wait a minute, let's start this down a different path to get this to resolution, whether it's picking up the phone or, okay, here's some new data to help inform how to make this happen.
Dude, I think it'll go the other way. I think somebody's going to call up on the business side and say, hey, the AI model sucks. We're getting our ass kicked and we need another one. And we're going to have to go through the deployment process again.
Probably.
Then it becomes an arms race on data, Mike. Who's got the most market knowledge?
There you go. All right. So if we think this through for a minute, how quickly do we think that these AI models, therefore, are going to be tuned and upgraded, and how continuous is that going to be over time? And, is this something that we're doing every day, once a month, once a year? What is the pace of the update cycle going to be like? See, I do have a method to my madness.
That's a good modesty question.
Yeah,
you can answer that best.
I'm happy to take that. It depends on the use case. That's not a great answer, but that's true. Some models say you're making loan decisions or predicting default. You will not have the results until, say, 3 months later. And so most people won't bother retraining until they have enough new data to train on. Versus if you think about Twitter feed ranking, then they have enough data every day where they can retrain and redeploy the model, and they used to, at least. Maybe they still do that. Ads is something that they're going to retrain every day, maybe even every hour, because they're trying to squeeze the most juice out of it. So these are, I would say, planned upgrades that will happen. There will also be reactive things that happen because there's a bug or an issue that's identified, and then people need to scramble, like we're showing inappropriate images next to ads. This used to happen and will happen a lot more with generative AI stuff. There's an inappropriate ad. Okay, we need to go and fix our model. So then let's fix it. Let's redeploy it. And so similar to software, there's like planned major versions, minor versions, and then there's patches because we forgot to do something. So I think we need to get our processes to a place where you can patch something quickly if you need to. Otherwise, you can fall back to a regular cadence.
And there's two paths too, right? One is the model, the other is the data. The data can continually be updated and tweaked or added to. The model might be more kind of rigorously refined, but both can go through a continuous delivery, continuous update process. Versus, I mean, like today with ChatGPT, we have great big releases, 3.5 to 4.0, and that's because they've done all this training to the models. Well, that's because it's a massive thing to exercise to go through that process. For things that are much smaller, we can do more incrementally. And I think that's ultimately what makes sense, because if it's going to take 4 months to do an update to your model, it might be necessary, but that might not work for the business. Those shipping containers already got bought and the phone calls happened and you missed your chance, model person.
So how much of these models will I need to get validated by somebody else before we deploy them? And I'm asking the question because let's say I'm a business executive and you show up as a data scientist with a model that tells me that, we execute this and our margins are going to go up through the roof. But it turns out that the data was somewhat, shall we say, limited. And that doesn't actually turn out to be the case. And then me as a business executive gets mad at you for selling me this bill of goods and whatnot. So how much do we need to make sure that these models work as advertised before they're deployed?
Oh, I have so many thoughts. This is like, if deployment is slow, at least people are doing it. Validation, a lot of people just don't do it. And they'll do it a lot more for their internal models. But a lot of businesses buy models, as you're saying, third-party models. And how to validate that your third-party model works on your data, it's surprising how little of that is done, unless, again, you're in the regulated industry and you must do that. I think that there will be more focus, and there needs to be more focus on model validators who try to stress test the model, just see where it breaks down, see where it works, where it doesn't, and do it in a context where you don't have access to the training data in your own systems. You have access to the training data. You can reason with it. What you're getting from a third party is a black box. And so it's very much like black box testing in a software scenario, or equivalent of penetration testing, but for models. And I think there's a few open source things that are coming up. And I hope there will be a lot more, because this needs a lot of attention.
I think you just said, don't let the AI fox guard the AI henhouse.
Well, there's a whole new field too, relative to AI, and that's around safety. And that is to make sure that AI models aren't, I guess the measure is trying to acquire power. And so, for example, when I think 4.0 was deployed, they went through an external review. I think it was the founder of OpenAI who started a new company as a process to go through and validate your model is not trying to gain power, right, over humans. It sounds a bit futuristic, but it's real, right? So, for example, you could create an AI model that might negotiate prices of something that puts 1 million people out of jobs because of something that you did. And is that what you want your model to be capable of doing? So there is the, concerns around AI doing bad things, but there are at least processes starting about how we can review models and make sure that they have a certain level of safety. Where that goes and how much that becomes of what we do, or we just move so fast it outpaces that, I don't know. But it's interesting that that's a field of study. I've never had software deployed. I had to go through and say, is it going to gain power through my Python code?
There's a couple of questions here.
So Mitch,
go ahead.
So Mitch, I was going to kind of go a little further on that. Is you're absolutely right, and Manasi started the ball rolling here with the discussion of model validators. To what degree do we mark our own homework as practitioners of AI and machine learning, and to what degree does there need to exist a national or global standard, a guardrail that we need to adhere to? We talked right at the top about some policies that are already in motion, but do they go far enough? And in whose hands should we put this power and authority?
Oh boy. You do ask easy questions.
I know.
Sorry, I'm honestly not picking on you today.
No, Manasi knows more about the regulatory framework. It's this whole question: do we pause? Which is like sort of tilting at windmills. No, nobody's going to pause, and you might ban it, but it's still going to make it in. It's kind of everything you do to try to stop it. So how do you direct it for a force for good versus bad? And well, let's take software and what's happening in the security world and malware. I think the better approach is it's not trying to stop it from happening only, but assume it's going to happen. And how do we handle it when it does happen? Because it will. I mean, you can plug every finger you have into every hole in every dike. There's going to still be a way water gets through, and this is going to happen. So, I mean, what the answer is to that, I have no idea, but I have to wait for the next Gibson book to come out to read about what we do about that. Snow Crasher 2.0 or something.
Yeah.
So there are multiple questions that kind of pointed at this particular issue, and I'm going to grossly oversimplify it. But if I understand like ChatGPT and where it sits today, it's this massive brute force approach, but it kind of ends on January 1st of 2022. And so now if I wanted to update this thing, I would spend the next 2 years collecting all the data, having a couple of humans kind of recognize the data. So, it might actually get to where we are today 2 years from now. So that seems like unsustainable. So is all this going to give away to much smaller data models for large language that are targeted for specific use cases? And we are going to see this kind of a lot of nuance in the applications, because we need things that are more narrowly focused, that are easier to update, that are more relevant at the time we need them. Does that make sense?
I think your question is kind of back to the large language models. Are we going to have specialized variations of that?
Lots of little specialized variations rather than these big giant things that are seemingly cool, but always a little out of date and maybe giving us some wonky answers from time to time.
Well, it's a good question, because you can make the argument of what makes ChatGPT work is it's the number of connections that it makes by the massive amount of data that's fed into it and is labeled. Can you do that on a much smaller basis? And like I gave the example for cancer, or does that need to be equally as large to produce accurate results? And Hamilton and Chat just posted, Chat GPT seems to be 90% accuracy. I don't know if that's a real number or he just said that, but I'm not going to do surgery based on a 90% accuracy AI model, right? So it's a good question. How large they have to be accurate, or are there other ways just besides the amount of data and amount of connections, nodes that are made? Manasi, you may have more insight into that. Is there a good answer to that challenge?
I think there will be lots of smaller models. I think that'll happen for two reasons. One is, to your point, like for use cases, you do need to fine tune, whether it's medical or writing marketing copy, and the other one being just the ability to update these models more quickly, because you will want to as you get new data. There might, and this is off the top of my head, there might also be a future where ChatGPT gets condensed in some way through techniques that we don't even know. So there's distillation and stuff, but I'm thinking even more novel techniques, and then it fits on a chip. And there are chips that are optimized for ChatGPT or GPT type things. So it's very efficient to run them. And then you have much smaller models that use that chip to do more. And so I think there's going to be lots of different kinds of models that are, building on top of GPT. I think they will be a lot smaller themselves. Also, it's just too expensive to run them. So that's going to be the driving force, is like we can't spend millions of dollars a day that Azure and OpenAI can. So we got to get it down.
All right, folks, you heard it here. It does come down to money at the end of the day. Hey, I want to thank our panelists for sharing their knowledge and insights, and it was a great conversation. I want to thank you all for watching this latest edition, and your contributions. Lee, you want to say a couple of words?
No, just echo your comments, Mike. We had a great session today, so thank you, Mitch. Thank you, Mercy, for contributing. Obviously, this has been recorded, so I encourage people to share it and visit both Techstrong and the AI Infrastructure Alliance communities for more on this topic. Thank you, guys.
All right.
Thank you so much for having me.
Cody, take us out.
Enjoy.
Awesome. Mike and Lee, thank you both so much for keeping this train on the tracks. And Mitch and Manasi, thank you so much for providing all of your in-depth knowledge. Thank you all so much for being here. So I would like to also remind our audience that this session was recorded. You can receive the recording via email. It will be sent to you in about the next day or so. But you can also find it living on the DevOps website at devops.com/webinars, and be sure to look in the on-demand section. The 4 winners of our $25 Amazon gift card drawing, they are Brooke L., Ali S., Cesar B., and Robert F. So to our 4 winners, keep an eye on your email inbox to claim your gift card. Should make its way over to you in about 48 hours, but if you don't happen to see it, check your spam folder just in case it gets filtered out. I'd like to thank the AI Infrastructure Alliance for sponsoring our program today. And to everyone who is still hearing my voice, thank you so much for being here. We really appreciate your time, and we want to hear your thoughts. So as soon as we close out, there will be a survey that pops up. Let us know what you liked about our program, or if you have suggestions for an upcoming panel, go ahead and let us know there. Either way, we hope to see everyone at a future Techstrong learning experience. Have a great rest of your day, and you may now disconnect. Lee, Mitch, Mike, Manasi, thank you.
Thanks,
Thank you.
everybody.